Hi guys, okay, this is paper 2, November 2021. Expand and simplify, okay, nice easy start hopefully guys. Multiply out the first bracket, we get 10x minus 5, and then multiply out the second bracket, plus 44 minus 4x. Simplify this, we have the 10x minus 4x is 6x, and we have the minus 5 plus 44, which is plus 39. That's just 44 minus 5. And then he wants it in this form, so you take out a 3, because 3 goes into 6 and 39, and we get 2x plus 13. There we go. Easy. Question 2. A. 5m is decreased by 40%. The answer is this. Work out the value of m. Okay, so if you decrease by 40%, you multiply by 0.6 because it's like getting 60%. So 5m times 0.6 is equal to m plus 1. Work out the value of m. I like the thought of guys saying that 0.6 is actually, well, sorry, I have a calculator. So 5 times 0.6 is going to be 3. So that's just 3m equals m plus 1. If you're not comfortable with that guys, just do 5 times 0.6 in the calculator. It's 3/5. 0.6 is 3/5, which is why I knew it. 3m, subtract the m, gives me 2m equals 1, and then m equals 1/2. Part B. Solve this equation. Okay, so we're going to cube both sides, guys. 2w minus 10. If you cube this side, you get rid of the cube root. And 18 cubed, right, for this, I'm going to have to use my calculator. This, guys, is 18. And cubed, I just press that button here. And then 3. And then 4832. Sorry, 5832. So this is 5832. Add 10 to both sides. I get 5842. And then divide by 2. Feel free to use your calculator, guys, but that is 2921. Okay, that is W. Part 3, question 3. The rectangle and triangle shown have equal areas. Work out the value of D over E. Okay, as always, they've given us very little space to work here. Okay, area of the rectangle, let's call it area rectangle, or this is equal to base times height, so that's just 12DE times 2D, which is equal to 24D squared E. Guys, let me just turn off the spelling here. This is going to annoy me. Okay, so that's 24DE squared. Let's do the area of the triangle. Let's do it over here, guys, because there's just so little space. Area of the triangle, let's call it T, is equal to this times this divided by 2. So it's 8E squared times 9D divided by 2. Which equals, guys, you can do 8 divided by 2 is 4, and 4 times 9 is 36. Or you can just do 8 times 7 is 72. 72 divided by 2 is 36. Either way, you get 36 E squared D. So this is the area of the rectangle, and this is the area of the triangle. It says they are equal, so let's make them equal. 24 D squared E equals 36 E squared D. Now, he wants D over E. So what I'm going to do, guys, is I'll divide both sides by E, which gets rid of this E and gets rid of this 2, if you like. And I'll divide both sides by D, which gets rid of this 2 and this D. So now we have, I'll just write this line, 24D equals 36E. He wants D over E. So what I'll do is I'll divide both sides by E, and I'll divide both sides by 24. So I get the D over E. I divide by E here, and I get the 36 over 24 here. And he wants it in its simplest form, divide above and below by 12, I get 3/2. Okay, that's 3. Question 4. Equations of 2 circles are shown, this and this. Work out the area of the shaded region. Okay, so guys, I don't think this is too difficult once you know the equation of the circle. So basically, guys, this radius here is 6 because of this here. This is the radius squared. And this radius here is 10 because this is r squared. 10 squared is 100. So I'm just going to do the area of the big circle minus the area of the small circle divided by 2. That's what I'm going to do. Okay, area, let's just do it here. Area big is equal to pi r squared, which is 100 pi. That's the area of the big circle. Area of small is pi r squared, or 36 pi. That's pi times 6 squared. Subtract them. Big minus area of the small is equal to 64 pi. And then it's a quarter. That would be like the full ring around, but it's a quarter of that. So I'm just going to do 64 pi over 4 is equal to 16 pi. And that's the answer. Okay, that is question 4. Question 5. SQR is a triangle. Okay, this is all given. Fine. Work out the coordinates of M. This is the midpoint of this and this. Okay, so guys, what I'm going to do is, I think first we'll find this point using this 45 degrees, and then we can find the midpoint. That should not be a problem. Okay, so if this is 6, guys, that means from here to here, this distance must be 9. Let me just show you which distance I'm getting. This distance here is 9 because it's 15 minus 6. The y coordinate is 15, y coordinate is 6, so that distance is 9. Now if this distance is 9, because that's 45 degrees, this distance must also be 9, because 45 degree angle means that the rise over the run is the same. If you like, it's a gradient of 1. It's like the perfect diagonal. So this is 9, which means this is 9. And if this is 9, k must be 10, because it's just 1 plus 9 is 10. So that's 10, 15. Now what's the midpoint of 1, 1 and 10, 15? Well, I can tell you straight away, guys. It is going to be, well, I can't tell you straight away, but it's 10 plus 1 over 2. Let me just do the working here, guys. It's 10 plus 1 over 2, comma, 15 plus 1 over 2, which is 5.5 and 8. So coordinates of M, 5.5, comma, 8. Okay, that's question 5. Question 6. Rearrange this. Make W the subject. Okay, first thing, get rid of the root, square both sides. Y squared is equal to x plus 2w over 3. Multiply across by 3. 3y squared equals x plus 2w. Subtract the x. 3y squared minus x equals 2w. And then w is 3y squared minus x over 2. 3y squared minus x over 2. Okay, done. Question 7. A is a value greater than 1. Work out the value of m for which this equals this. Okay, so guys, let's just sort out these powers. A power to a power means we multiply the power. So a to the 4m, that's just m times 4, equals a to the 5 times 2m is 10m. Okay, so we have 4m must equal 10m. 4m equals 10m. The only way this can be true, guys, is if m equals 0. You can subtract 4m here if you want to. You get 6m equals 0. 6 times what equals 0? Well, it has to be 0, so m equals 0. Write y in terms of w and x. Okay, that's not difficult, guys. Let's get the y to the 5 here. We've our w to the 13 times x to the 7 over w to the 3 x to the 2. Okay, this equals, I just need to, guys, subtract the powers for the w. So that's going to be w to the 10 and subtract the powers here, and I get x to the 5. So it's just y equals w to the 10 x to the 5. Question 8. Function f is given by this. So this is a piecewise function, guys. A sketch of the graph is here. Work out all the values of x for which f of x is equal to negative 12. Okay, so negative 12, guys, it's going to be, okay, if this is negative 16, negative 12, let's just say, is somewhere around here. Now I'm going to draw a line across like that, just to show you there are 1, 2, 3, 4 values of x. There are 4 solutions because it equals negative 12 here, 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 and here. One of them will be for this, 2 of them for this, and 1 of them for this. So what we basically do is we have to solve each equation separately. Let me do the 4x one here. So 4x equals negative 12, x equals negative 3. Okay, that one's easy. Let's also do this 16 minus 2x one here, guys. 16 minus 2x equals negative 12. That means 2x. If I add the 2x here and add the 12 there, this equals 28, and x equals 14. Okay, so that's the solution. And then this one, the quadratic, let's do it here. X squared minus 8x equals negative 12. Quadratic, solve it. X squared minus 8x plus 12 equals 0. Factorize this. I'm going to go with, guys, 6 and 2 because they both have to be negative. So x minus 6 times x minus 2. Those multiplying together will give me 12. Add them will give me minus 8. And that will give me, finally, x minus 6 equals 0, x equals 6. Or x minus 2 equals 0, x equals 2. So I have my solutions: minus 3, 2, 6, and 14. So x equals minus 3, 2, minus 3, 2, 6, and 14. Okay. Question 9. Circle the expression that is equivalent to this. Okay, guys, so I need a common denominator of a times b. Not a plus b, so it's one of these two. But it's definitely going to be this one, because when you get your common denominator, you have to multiply this one by b and this one by a. You certainly can't just add 1 plus 1. Okay, so that is correct. This one. Okay, numerator, I can take out c cubed. Okay, so I'm going to have c cubed into 6c minus 1. Okay, great. And the bottom, hopefully you recognize it, guys. It is a difference of 2 squares. So this is 6c plus 1 times 6c minus 1. If you don't know that rule, guys, you need to learn it. It's a very useful rule that appears all the time with factorizing quadratics. So it's a difference of 2 squares because 36 is 6 squared. So it's 6c all squared minus 1. So minus 1 squared, which is this times this. Okay, these two cancel nicely, and we're left with c cubed over, sorry, I canceled the wrong one. This one cancels with this one. So we're left with c cubed over 6c plus 1. Okay, that's 9. Question 10. The radius of a sphere is this. The volume of a sphere is this. And it gives us the formula for the volume of a sphere. Work out the value of k. Okay, so guys, we are going to say 4 over 3, this is from this formula, times pi times the radius, 3k over 2, cubed equals this, 972 pi. Okay, first thing I'm going to do, guys, is divide both sides by pi. Nice. Then I'm going to say 4 over 3. I'm going to cube this, so I have to cube everything, guys. 3 cubed is 27. K cubed is k cubed. 2 cubed is 8. Brackets, 972. Okay, next thing I'm going to do 4 into 4 goes once. 4 into 8 goes twice. Divided below by 4. 3 into 3 goes once. 3 into 27 goes 9 times. Okay, now I have 9k cubed over 2 equals 972. K cubed equals 972 times 2 divided by 9. I'm going to go over here, guys, because as always, I don't have enough space. So k cubed equals, let's do this, 972 times 2 divided by 9, 216. And I know the cube root of 216, guys. You can use your calculator if you want, but the cube root of 216 is 6. So answer, k equals 6. Expand and simplify. Okay, let's just do 5x times 4x is 20x squared. This times this is minus 5x y squared. This times this is plus 12x y squared. And this times this is minus 3y to the 4. Okay, simplify this, guys. I get 20x squared. I get minus 5 plus 12 is plus 7xy squared, and minus 3y to the 4. Done. Question 12. A and B are points on the line y equals 3x plus 2. B, C, and D are points on the line L. OA to AC is 1 to 4. Okay, so this is 1 to 4 here. That's 1 to 4. Work out the coordinates of B. Okay, so let me just think a second, guys. If this is 1 to 4, then these intersect. Okay, so hang on. Let me first find this coordinate, guys. If this is, sorry, this coordinate there is 2 because it's the y-intercept here. So this is 0, 2. Now if this is 2 and this is 1 to 4, if this is 2, this must be 4 times 2, which is 8, but it's like 2 plus 8. So this coordinate here is 10. Okay, so that coordinate there is 0, 10. Okay, now he says this is 5, 0 here. Okay, this is 5, 0. Now I think I can get the equation of this line now. It is, I can actually just get the gradient. So this line here is y equals, the gradient is 10 over 5, rise over run, but it's negative. So it's negative, let me just write here, m, this guy, gradient is equal to negative 10 over 5, which is negative 2. So this line here is y equals minus 2x plus 10, because the y-intercept is 10. So now I have minus 2x plus 10. This is y equals 3x plus 2. I just need to find the x coordinates, so I can just equate them, because this is where they meet. Where two lines meet, you can just equate them. And I get 3x plus 2 equals minus 2x plus 10. Add this over here, I get 5x. Subtract this over here, I get 8. So x is equal to 5 over 8. Sorry, 8 over 5. 8 over 5, or 1.6. That's 1.6. Okay, question 13. P is the point on the curve, this where x is 2. The gradient of the normal to the curve at P is minus 1 over 4. Find the value of A. Okay. Okay. The gradient of the normal. So definitely, guys, I want to get the derivative here. dy dx. The derivative, when I see normal, I think derivative. Do it anyway, guys, you get a point. Derivative of this, I do multiply by the power, so it's 3ax, subtract 1 from the power, it's 2. Plus multiply by the power, 2 times 10 is 20, subtract 1 from the power, it's 1, so just x. Okay, this is the derivative. Now, at x equals 2, dy dx equals 3a times 2 squared plus 20 times 2, which equals, that's 4 times 3 is 12, 12a plus 40. Okay, now this is the gradient of the tangent. The gradient of the normal is minus 1 over 4. So the gradient of the tangent, let me just write it up here. Gradient of tangent is the negative reciprocal. So I make it positive and I make it 4 over 1, which is just 4. So that means this must equal 4. So I do 12a plus 40 equals 4. 12a equals 4 minus 40, which is minus 36. And then a is equal to negative 12. No, that's not right. It's equal to, 36 divided by 12, which is negative 3. Okay, done. 13. Question 14. Describe geometrically the single transformation represented by A. Okay, so guys, I do these questions like this. I'm hoping you've seen something similar. So this is 1, 0, and this is my 0, 1. So this is my 1, 0, and my 0, 1. Now, or I can put them in point form, guys, if you want. This is 1, 0, 0, 1. The end of these arrows, if you like. Okay, now these have turned into 1, 0, 0, minus 1. So what happens is this first guy stays the same, and the second guy has now gone to 0, minus 1. So look, this is the blue one. This is the blue guy, my 1, 0, and the red guy has gone to 0, minus 1. So the blue guy stays the same, and the red guy goes down to here, 0, minus 1. Now, if he stays the same and he just flips down to here, what is it? Well, it's a reflection. It's a reflection in the x-axis, or y equals 0, whichever way you want to call it. But you get full marks for x-axis, guys, so just stick with that. Okay, b is equal to this. Describe geometrically the single transformation represented by b squared. Okay, so first let's get b squared, guys. 0, minus 1, 1, 0, times 0, minus 1, 1, 0. So I do the row times the column. Top left, 0 times 0, 1 times minus 1, I get minus 1. Top right, 0 times 1 is 0, 1 times 0 is 0. Bottom left, 0, 0. And bottom right, minus 1, 0. So that is the matrix B squared. Now again, let's go to this grid or graph here. My 1, 0 is here. This is my 1, 0, and my 0, 1 is here. Okay, now the 1, 0 has gone to minus 1, 0. So this guy has gone over here. The blue one has gone over here to minus 1, 0. And the red one has gone over here to 0, minus 1. Now what has happened? If he's gone here and he's gone here, it can't be a reflection, because if you reflect in the y-axis, he doesn't move, and if you reflect in the x-axis, he doesn't move. So it's not a reflection, so it has to be a rotation. So it's just rotated, the whole thing is rotated, it is rotated 180 degrees, because he's gone, look at it, this guy has gone to there, 180 degrees, and he's gone to here, 180 degrees. So it is a rotation of 180 degrees. The direction actually doesn't matter, because 180 degrees is the same clockwise or anti-clockwise, but you do need the center 0, 0. Okay, that's 14. 15. ABC are points on a circle. ACD is a straight line. Angle BCD is equal to W. Okay, prove that W equals X plus 90. Okay, so we want W equal X plus 90. Okay, first and foremost, guys, let's just start drawing things on this. So this is equal to X there. That has to be X, because these are both radiuses. Okay, X and X. This is therefore 180 minus 2x, because the full triangle is 180, and I minus x, which is minus 2x. Okay, that means this guy is half that, because the angle at the circumference is half the angle at the center. So this is equal to 90 minus x. And then finally, W plus 90 minus x must equal 180, because this is a straight line. Okay, all we need to do then is kind of just, well, we just subtract 90 from 180, and we get 90, and add the x over here, so I get plus x, which is what we wanted. Okay, now guys, just to be clear, when you're doing a proof, you gotta explain what you're doing. So here, you want to write isosceles triangle. Here, angles in a triangle add up to add to 180. And here, angle at circumference is half angle at center. And then finally here you want to say angle in straight line angles in a straight line add to 180. Now I know, guys, that's obviously annoying to write all that, but you got to do it to get the full 5 marks, so just be careful. Okay, that is 15. Question 16. The coefficient of x to the 4 in the expansion of this is 1/500. Work out the 2 possible values of a. Okay, first and foremost, guys, I need Pascal's triangle. Let's draw it down here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I need to go to 6. 1, 4, not that 6, 4, 1, 1, 5, 10, 10, 5, 1. This 6, 1, 6, 15, 20, 15, 6, 1. Okay, Once I have that, I can write that this thing here is equal to 1 bracket plus 6 bracket plus 15 bracket plus 20 bracket plus 15 bracket plus 6 bracket plus 1 bracket. I know you don't need to write out the full thing here, guys, but I just find it is so easy to do this the same method all the time. So in the first one I put A, so I get A. Second one goes 2x, 2x. Okay, then the powers here go down. 6, 5, 4, 3, 2, 1, 0. And here they go up. 0, 1, 2, 3, 4, 5, 6. Okay, the one we want, guys, is this one, because he's got the x to the 4 in it. Just by signaling this is the one you want, you'll get a mark, guys. Okay, so then I can say that this is equal to 1500. Well, 1500 x to the 4. So I can say 15a squared times 2 to the power 4. Be very careful here, guys. This is a mistake that many people are going to make. You have to do 2 to the power 4. So it's 16 x to the power 4. That must equal to 1500 x to the power 4, if you like. He's saying the coefficient. So essentially, you can remove the x to the power 4 at this point from both, though. So it's like the coefficient is equal to 1500. So without the x to the power 4. But I wanted to show you what's happening. Okay, so then we have this. I'm going to just divide both sides by 15, guys, because it's quite nice. So 16a squared. 16a squared is equal to, divide by 15 is 100. A squared is equal to 100 over 16. So a is equal to plus or minus square root of 100 is 10 and square root of 16 is 4. So it's plus or minus 10 over 4, or let's simplify that to 5 over 2 and negative 5 over 2. Okay, that's question 16, guys. Question 17. We have a cube, side length 32. Work out the size of the angle that the line BM makes with the plane ABCD. Okay, this is confusing. BM ABCD. So what he's actually looking for is this angle here. Let me just draw it like that. This is the angle he wants. Let's call it theta, because it's the line that this is the angle that this line makes with the plane. The plane is like the bottom of the cube, the base of the cube. Okay, now we know the base is 32. So this is 32 here. This is 32 here. This is 28 there. Okay, I think I know what he's doing now, guys. If this is 28, this is also 28, because these are alternate angles. Okay, so that's 28. This is 32. So now I think I can find this angle, or this side here, guys. That side there. I can say tan 28 is equal to, let's call this x. Let's call it x there. So it's x over 32. So x is equal to 32 times tan 28. Let's give an answer for that, please. I want 32 times tan. Now, guys, I just noticed I'm in radians, so just be careful. Calculator settings. I want degrees. Thank you. Okay, do that again. 32 times tan 28. Now I'm back in degrees. And I get 17 point, let's do 015. 17.015. Okay, if x is 17.015, what is this green length here? Well, let's call it y. Y must equal 32 minus 17.015. Okay, let's do that calculation. 32 minus 17.015, which is this. I want decimal, please. 14.985. 14.985. Okay, now I have, guys, the green line. What I don't have is this this blue line. Let's call this, I don't know, let's go with Z. But I can use Pythagoras' theorem because this is a right angle, guys, because it's the base of a cube. So I can say Z squared equals 32 squared, 32 squared plus 32 squared, and then let's just go straight to the square root of that. I want the square root of 32 squared plus 32 squared. 32 root 2, okay, fine. 32 root 2, that's Z here. And now finally, I can say theta, I can say the tan of theta is equal to opposite, which is the y, 14.985, over the adjacent, which is the z, 32 root 2, and then theta is equal to inverse tan of that, guys. So I'm going to do inverse tan fraction 14.985 over 32 root 2. I feel, guys, this has to be right. 18.32. So I get 18.32 degrees, and that is right. Okay, difficult enough question, guys. That is question 17. Now, question 18. Y equals this. Show that y has a minimum value when x equals 0.5. Okay, minimum, guys, I want derivative. dy dx. dy dx equals, well, actually, sorry, first let's rewrite this as y equals 12x plus 3x to the minus 1. Always change it first and then differentiate it. So the derivative, dy dx, is equal to 12 minus 3x to the minus 2. That is the first derivative. Okay, at x equals, no, sorry, I'm not doing it at x equals 0.5. We need to show that it's at 0.5. So at a minimum, at min, dy dx equals 0, and d2y dx squared, the second derivative, and this is going to be part of our proof, has to be greater than 0. For a minimum, because it's concave up, the second derivative is positive. Okay, so first let's get the first derivative equals 0. 12 minus 3 over x squared. X to the minus 2, guys, is 1 over x squared. So this is 12 minus 3 over x squared. This has to equal 0. Let's bring this over here. 12 equals 3. 12 equals 3 over x squared. X squared equals 3 over 12. That's just rearranging, or a quarter, which means x is equal to plus or minus the square root of a quarter, which is plus or minus a half. Okay, now he says show that the minimum is at a half. Now I know a stationary point is at a half, but I don't know if it's a min yet. So we need the second derivative. d2y dx squared equals, I'm going to differentiate this. So I'm going to get 0, the derivative of 12 is 0. Then minus 2 times minus 3 is plus 6x to the minus 3, or 6 over x cubed. At x equals a half, the second derivative, d2y dx squared, equals 6 divided by a half cubed. Now guys, you can do that on your calculator if you want, but that's actually 6 divided by an eighth. A half times a half times a half is an eighth. 6 divided by an eighth is actually equal to 6 times 8, which is 48. So you can then say, as 48 is greater than 0, minimum at x equals a half. And we don't even need to show what's happening at the negative half, because he never asked us. We just need to show that the minimum is when x, that it is a minimum when x is a half. Okay, question 19a. F of x equals this. G is a function such that g of f of x equals this. Work out an expression for g of x. Okay, so I think, guys, that's actually quite easy. So g of f of x equals x plus 2 to the 12. So x plus 2 cubed. What do we need to do to that to get x plus 2 to the 12? So let me just write, this must equal x plus 2 to the 12. How can I make this equal to this? Well, I just have to raise it to the power of 4, because then when you raise this to the power of 4, you multiply the powers and you get 12. So what is the function for g of x? Well, g of x has to be the input, which is x, to the power of 4. And then when you put f of x into this, you get this to the power of 4. Okay, that's only worth 1 mark. 19b. H of x is equal to this. K is a function such that k of x is equal to 4x squared plus 5. Work out an expression for kh of x. Okay, okay, h of x is this. H of kx, h of k of x is equal to this. Okay, so essentially, guys, what we're going to do is say, what does he input into h to get to this, right? H of x equals, h of x is equal to x squared plus 5. Okay. H of what? H of what is equal to 4x squared plus 5. So you have to kind of reverse engineer this. What do you put in instead of x to get 4x squared? Well, the answer, guys, hopefully you've seen it, is 2x. Because if you put 2x into this, you'll get 2x squared plus 5, which is 4x squared plus 5. Okay, so h of 2 of x is 4x squared plus 5. Therefore, k of x is equal to 2x. So when he now says find k of h of x, to find k of h of x, we need to just put k of h of x, we need to put h into k. So it's 2 times h, which is x squared plus 5. And then, well, sorry, that's it. And this becomes, well, it's 2x squared plus 10 if you like, or that is correct, or 2x squared plus 10. Okay, that's question 19. Question 20, nearly done, guys. Show that this over this minus this can be written in this form where a and b are integers. Okay, so let's have a think. So we have 2 sine x plus cos x. Now, the identities we need to remember that we have, guys, are tan of x equals sine x over cos x. That's in the formula sheet. And the sine squared x plus cos squared x equals 1. I'm not sure if we'll need that one. I'll write it if we do. But this is the first thing that I think we're definitely going to use. This tan is sine over cos. And then we're going to do minus 1 over sine x. Okay, now if we do our keep, change, flip, guys, if you like, we have, we're going to flip this and multiply by this. So we're going to have 2 times, okay, let me just do 2 steps, guys, just so you can see it clearly. It's 2 sine x plus cos x. That's the numerator. Times, and I'm going to flip this, cos x over sine x, like so. And this minus 1 over sine x. Okay, because I'm multiplying out, I have to do this times this. So this is equal to 2 sine x cos x plus cos squared x, because this times this is cos squared x, and then minus 1 over sine x. Okay, nearly there. So cos squared x, guys, cos squared x minus 1. Okay, so we do need that other identity. So I have, let me just write it down here. I have sine squared x plus cos squared x equals 1. Now, if I do, guys, if I do this, I'm going to say cos squared x is actually equal to 1 minus sine squared x. So now I'm going to change this cos squared into 1 minus sine squared, and you'll see why this will work in a second. So I'm going to do 2 sine x cos x plus, instead of cos squared x, I'm going to do 1 minus sine squared x, and then minus 1. And this is all over sine x. Now the reason I like this is because the 1's cancel, and I know I'm going to be able to cancel a sine as well. So 1's are gone. That's nice. Gone, gone. And I'm going to factorize out a sine here. So I have sine x into 2 cos x minus 1 sine x, so just minus sine x. And this is all over sine x. These two cancel, and I'm left with 2 cos x minus sine x, which is basically what they wanted. A is going to be 2 and b is negative 1, but that is correct. Okay, so this is equal to 2 cos x minus sine x. Okay, last question, guys, I believe. 21. 3x squared plus 2bx plus 8a can be written in this form. Work out the 2 possible pairs of values of a and b. Okay, so guys, this is a completing the square question, but it's obviously not an easy one. So I'm going to take out the 3 first out of this. Okay, so I have 3 square brackets. I then have x squared plus, I need this divided by 3. So it's 2b over 3x. And then I'm just going to do the plus 8a over on the side. Okay. Then I'm going to complete the square inside the square bracket here. So I have x plus, I have to half this. So half of this is 2b over 6. 2b over 3 and divide by 2, 2b over 6. Square this, and then I have to subtract this squared. So I subtract 4b squared over 36. Now note this is still all in the square bracket, and there's a plus 8a out here. Okay, now let's multiply out this 3, or multiply in the 3. So I get 3 into x plus 2b over 6 squared. The 3 times this, now bear in mind guys, this is actually 1 over 9. So when I do 3 times this, it's 3 over 9, which is 1 over 3. So this is going to be minus b squared over 3. Just make sure you're clear on how I did that. And this is plus 8a. Okay, now I've written it in the way he wanted it, kind of, but it's a completed square. So basically, this a here, I have a 3, he's a 3, fine. I have an x, he's an x. But this a here must equal this here. And this b plus 2 must equal all of this. So he says 2 possible pairs of values of a and b. So let's equate them. We'll make 2 equations and find out what's going on. So I can equate 2b, and by the way, this is just b over 3, guys. I could have done that. Yeah, I could have done that straight away, but whatever. So this is 2b over 6, or b over 3, but let's leave it as 2b over 6 for now. 2b over 6 must equal a. So 1, 3, b must equal 3a. And then over here, let's equate the yellow one. Minus b squared over 3 plus 8a must equal b plus 2. Now we know, guys, that b is equal to 3a, or let's just leave a as b over 3 because I think this is the easier one to sub in. So now I have minus b squared over 3 plus 8 times b over 3, that's me just subbing this in here for a, equals b plus 2. Okay, guys, obviously this is a tricky question. So let's multiply across by 3. Minus b squared, multiply everything by 3, plus 8b equals 3b plus 6. Okay, bring everything to the left. Minus b squared plus 5b minus 6 equals 0. Let's change all the signs across. B squared minus 5b plus 6 equals 0. Factorize this. I'm going to go with 3 and 2, minus 3 and minus 2. So I have b minus 3 and b minus 2 equals 0. So I have b equals 3 or b equals 2. So my pairs of solutions are, when b equals 3, a equals from here, a is b over 3. So 3 divided by 3 is 1. And when b is equal to 2, a is equal to 2 divided by 3, which is just 2 over 3. So my pairs are 1 and 3, or 2 and 2/3. And that's it, guys. That is the end of questions. Thankfully, paper finished. Yeah, hopefully that makes sense. Any questions, please ask me below in the comments.